classwork side is sort of the notes side. We'll work through a bunch of these together. And then the reverse side says homework. So that's the homework assignment side of things. All right, well, the rules are right there in the top. Like that's all there is in terms of notes for today is like, there it is. That's your notes. Let's compare that to yesterday, though. Maybe it would help if we put both rules next to each other. The derivative of inverse sine, let's see, was 1 over square root 1 minus x squared. Okay, well, this matches up pretty close. The square root is there, the minus is there, but there's an a there, so we have to be careful about the a. It's going to mess with us a little bit. Same thing with inverse tangent. That's the easier one. There's not a square root, and it's addition. So going backwards, doesn't necessarily have to be a 1 there. Could just be it can be anything there. A is just a number. And then the u and du stuff. So there's going to be some more u substitution going on today. All right, I think the easiest thing to do is just start working through them, and we'll see how far we get. So looking at number 1, well, which one does it look like? Inverse sine or inverse tangent? Inverse sine. And it's really not necessary for this one, but on a lot of these, it's helpful to write out what u is and what a is, because then it's a little bit easier to follow the pattern. For this one, u would just be x and a would just be 1. So inverse sine of x over 1 plus c. And obviously the over 1 is not necessary, but it reminds us of the role that a will play. Good? Okay. Right, because if this is negative, that's the cosine one, but you just pull it out front and then it's an inverse sine problem. So we don't have to worry about getting inverse cosine for the answer to an antiderivative question. All right, look at it number 2. Does that look like inverse inverse sine or inverse tangent? Oops, I heard both there. Sine, because it's got the square root. So who's in the role of u? Starring as u is x, and in the role of a is 2, right? So be careful, that's a squared right there. So a is 2. And I don't really have to worry about chain rule. I guess I could write it down. du is dx, so that's fine. So this is inverse sine of u over a, x over 2, plus c. Number 3. Does that look like inverse sine or inverse tangent? Tangent, right? There's no square root in there. And a would be 1 and u would be x, so this is just a very straightforward one. In fact, we could almost look at the derivative rule over here and see that if we go backwards from that, we get inverse tangent of x plus c. All right, number 4, we start to get a little bit crazy here. Well, I guess first of all, does that look like an inverse sine problem or an inverse tangent problem? Sine, because the square root. But not a square root problem like we did in warm-ups, because if we let u be the bottom, or not all the bottom, but the inside of the square root. So this is the tricky part. This isn't right, but if we let u be 5 minus 2x squared, then du would be negative 4x, and there's not a negative 4x up there. So that approach wouldn't work. Then hopefully we recognize, well, if it's a square root in the bottom, maybe it's inverse sine. So let's try to match up a squared and u squared. So what's a equal to? Square root of 5. And what's u equal to? Well, square root of 2 times x. Be careful, make sure it's clear the x is not part of the square root. But then dx is kind of mixed up in this. Du would be not 1. If u, so forget all the rest of this stuff, is u is the square root of 2 times x, then du is you're making this square root of 2 is just a number, right? Just a constant floating outside. So the derivative of square root of 2 times x is just square root of 2. Oops, I said square root of 2 and then I wrote the wrong thing. Square root of 2 dx. So let's see, how are we looking here? I'm trying to match this up to the box up top. I've got a squared and u squared. I need the top to be du. So we're used to this. The top needs an extra. What's the top need so that it matches, so that it's du? The square root of 2 up there. Then the top would be du. And that means I need a 1 over square root of 2 out front. So 1 over square root of 2, antiderivative of du over the square root of a squared minus u squared. Now it looks exactly like I want it to look for an inverse sine problem. Clean it up a little bit. So 1 over square root of 2, still just going along for the ride. Square root in the bottom is inverse sine of u over a. So u over a, I'll show it. U over a plus c. Some of you would have sort of substituted u and a back in kind of on the fly, and that's okay. U is square root of 2 times x, and a is the square root of 5 plus c. So that one was a little trickier because of the u and the a. So we're used to doing u substitution. A lot of that continues, but now we also got to account for the a. At least there's no dA to worry about. So it is a little bit trickier, but hopefully not too much trickier. How about number 5? What does number 5 look like? What's that? Yeah, like number 4, but there's an x on top, so that's kind of important. And by kind of important, I mean super important. So does that look like inverse sine or inverse tangent? That's kind of a trick question. Well, it looks a little bit like sine, but sine doesn't have an x in the top, or inverse sine doesn't have. So if we let u be the denominator, or at least the inside part of the denominator, what's du? Negative 4x. Well, that's good news because that's the top. negative 4 and negative 1/4. So the top is all du. And so this turns out to be a power rule problem, not an inverse sine or inverse tangent at all. In fact, this is really similar to the one we did in the warm-ups. Nick, what's negative 1/2 plus 1?
I don't know, man. 1/2. 1/2.
Okay. Yes, sorry. And then divide by the new power, so I need a times 2 out there. Plus c. So negative 1/2. 5 minus 2x squared to the 1/2 plus c. So yeah, that wasn't an inverse sine or inverse tangent. But the big difference there between 4 and 5 was that x in the top. That was kind of the clue that, wait a minute, this is not inverse sine or inverse tangent, this is something else. Speaking of something else, what does number 6, I'm looking at the 9, it said 6. Does it look like inverse sine or inverse tangent? Looks a little bit like inverse tangent. But if we were going to make it inverse tangent, let's see, then a would be 3, that'd be easy. U would have to be e to the 1/2 x, but then that's not what we have in the top. So if we u sub the denominator, though, then du is e to the x. Oh, that's good news, because that is what we have in the top. That's not inverse sine or inverse tangent. What's antiderivative of du over u? Natural log of u. Oh, and I didn't even need the absolute value bars on that, because 9 plus e to the x is always positive. But it's not wrong to put them there. Number 7. Does that look like inverse sine or inverse tangent or neither? Or both, or some combination of things?
It's sine, but it's not sine.
It's sine, but it's not sine. That's a pretty good answer. That's probably a really good answer. Because if it was, which part of the top would make it be sine and which part would make it be not sine?
The x would make it sine, but plus 2 is sine.
I think it's the other way around. Right? Just the 2 would be inverse sine. But just the x would be u substitution for the bottom, and du would be the top. Well, why don't we do it this way? Why don't I just unadd like somebody added a fraction here. Let's just unadd that fraction and split it up. And so now, Tyler, you were right. Part of it looks like inverse sine and part of it doesn't. But we were able to split it up, and now we can handle the part that doesn't look like inverse sine and the part that does look like inverse sine. Oh, let's see. Yeah, these are almost like two separate problems here. I'll just combine them at the end. So for this first piece, that's the one that doesn't look like inverse sine because there's an x in the top. So how should I handle that? U the bottom. Yes. So if we let u be the bottom, that's good. Then du is pretty close to the top. Close enough to fix it, to be fixable anyway. So -1/2 antiderivative of u to the -1/2 du. Like we've already done this problem 2 times today. This is the 3rd time through on this one. We won't put anybody on the spot on adding 1 to -1/2. All right, so there's the first part. I could put plus c on that, but I'm going to just wait till the very end and put plus c for all of it. So, I mean, it wouldn't be wrong to put it there, but I'm just kind of waiting for the end, and I'll catch it all at once. All right, if this is inverse sine, and it is, that means I need to start matching up who's a and who's u. So a would be 2, u would be x, so this actually isn't too bad. Du is dx, so I'm not worried about that one. So I think all I really need to do is to take this 2 and put him out front. I guess if I want to show the step, I could. This is now du over the square root of a squared minus u squared. Some of you will not write that step because you'll just kind of see that that's what you've got in its inverse sine. So 2 inverse sine of u over a, x over 2, plus c, but I'll put the plus c here at the end. So 2 inverse sine x over 2, and then this like giant plus c that goes to everybody. What a lovely problem that was. Well, having just done number 7, look at number 8. Well, yeah, it's kind of the same thing. I'll split up the top, and one of them will be a u du kind of thing, and the other one will be an inverse tangent. So I'm going to press pause and let you try number 8. That's a dangerous proposition. I know u is going to be x squared plus 4. That means du would be 2x. I'm kind of u substituting on the fly on this one, or in my head. So that's going to be du over u. So I know this one's going to be natural log of x squared plus 4. In fact, that's not too bad to check, because it would be 1 over x squared plus 4 times 2x, and then the 1/2 would cancel that. So I feel good about that one. This one, maybe not, because I haven't done too many tangent problems. So if I let u be x, and a is 2, and this 2 is just kind of in the way, so I'm going to move him out front. Now I'm just looking at the box up there. It's 1 over a. So that is not in the inverse sine, but it is in the inverse tangent, that extra 1 over a. Inverse tangent of u over a plus c. And sure, the 2 and the 1/2 would cancel, but just really embrace the safe stop thing, right? Why mess with that? So that was another split them up problem. All right, a few people heard me say this earlier, but this tangent has an extra 1 over a out front, and sine doesn't. That just feels weird that happens. The only way I remember to work it that way is that tangent had an a in it, like the word tangent has an a there, and so that's my reminder that I need an extra a for tangent, but not for sine. Whatever you need to do to remember that the tangent has the extra a. Number 9. Thoughts on number 9? Yes. Algebra first. And when you say algebra first, be a little more specific. No, he put you on the spot. So there's a rule that we don't like using this rule, but if the top has a bigger degree than the bottom, no. How do I handle it, or what am I supposed to do if the top is bigger than the bottom? Just say no.
Not continuous.
Not continuous. No. None of those things. What do I have to do if the top degree is bigger than the bottom degree?
Oh my god.
Greater than or equal to.
Top code, top, no, bigger, equal
It's
to.
not division, is it?
It is division.
Oh,
People are throwing things now. I have to long divide.
Oh, no. Wait, it cannot be synthetic, can it?
Exactly. I can't synthetic divide because that's x squared. Our math our department chairman texted me and the other calculus teacher last week, and said, do we ever really need long division? Why do we need that? And we're like, oh, you do need long division. We're doing it this week, in fact. Wouldn't want those poor underclassmen to miss out on long dividing. Let's see. Something times x squared would get me x cubed. Well, that would be x. Multiply it back. X times x squared would be x cubed. X times 1 would be x. Then we subtract those. First one goes away. We get negative x. Here's the trick, though. What do I do with negative x? Like, how do I sort of finish this problem?
It's a remainder.
It is a remainder. That is one answer. That doesn't help me here.
Over x squared plus 1.
There you go. So you weren't wrong. It's just that's not really how we want to work this problem. So that's not the answer. That's just rewriting the integrand. So actually, that one turns out to be not too bad. First one would just be x squared over 2. How are you going to handle the second one? It looks a little bit like inverse tangent. Is it inverse tangent? Some very hesitant, not sure nods.
it's got the X.
It's got the x in the top, though. So that's going to be a u substitution thing with a natural log.
Did you do power rule to the first one?
First one would just be power rule. Second one, see if we can do this on the fly. This is not smart to not show my work here. So I know it's going to be that, but that derivative would have a 2x. So I think I would need a 1/2 out front to make that work. All right, on the back, some of these are a little trickier. So let me give you some hints on these. For number 4, if you let u be t squared, like why would I let u be t squared? Because that doesn't seem like it would show up.
The derivative's on the top.
It'll be there.
But then the derivative's on the top. And then you'd have, is this going to be inverse sine, inverse tangent, or neither?
It'll be a good old sign.
It is going to be a sine, because if u is t squared, then t to the fourth is u squared. And so that is an inverse sine problem. Six is kind of goofy. Look at what you've got.
Sign to the -1x.
For what?
Sign to the -1x.
What about sine to the negative 1x?
We can do something with it.
You can.
The stuff we did a couple days ago. Never mind.
No, don't want to do that. If I let u be inverse sine of x, the derivative of inverse sine is, oh, what are the odds of that? That's good news for us. On number 7, what does that one kind of look like? Because if you're thinking u substitution and you let u be the bottom, that squared thing is messed up.
It's a true identity.
No, it's 1 minus cosine squared. So a good idea, but not quite.
Does that one equal, is 1 plus cosine squared equal like?
So it looks a little bit like tangent if u is, especially if u is cosine. Then this would match up inverse tangent. Du then is negative sine. So we end up with du over 1 plus u squared. That looks like inverse tangent. And then number 8. We did one kind of like number 8, but this one's not like the one we did.
Make it e to the 2x.
Because then this is a squared plus u squared, and the top is du, or close to du anyway. So 2 and a 1/2. A is 3, and this is inverse tangent, so be careful. Inverse tangent has the 1 over a out front. So that'll get you started on those. All right, tomorrow is just more practice of the same stuff. Friday we'll review, Monday we'll test. I'm going to go ahead and give you, and it'll be posted in Schoology soon enough, the other 2 worksheets.